Hi, my name is HUMA JAMSHED. I am PhD student at University of Karachi, Pakistan. I will be presenting my research paper here today. The topic of my research paper is data preprocessing, a preliminary step for web data mining. This research was conducted by 5 authors, and by the grace of Allah, we were able to achieve fruitful results. Abstract. In recent years, immense growth of data, that is big data, is observed, resulting in a brighter and more optimized future. Big data demands large computational infrastructure with high performance processing capabilities. Preparing big data for mining and analysis is a challenging task and requires data to be pre-processed in order to improve the quality of the raw data. The data-intense representation and quality is foremost. Data preprocessing is preliminary data mining practice in which raw data is transformed into a format suitable for another processing procedure. Data preprocessing improves the data quality by cleaning, normalizing, transforming, and extracting relevant features from the raw data. Data processing significantly improves the performance of machine learning algorithms, which in turn leads to accurate data mining. Knowledge discovery from noisy, irrelevant, and redundant data is a difficult task. Therefore, precise identification of extreme values and other outliers filling up missing values poses challenges. This paper discussed various big data preprocessing techniques in order to prepare it for mining and analysis tasks. The keyword for this paper are big data, data preprocessing, data mining, data preparation, text preprocessing. Hi, my name is HUMA JAMSHED. I am PhD student at University of Karachi, Pakistan. I will be presenting my research paper here today. The topic of my research paper is data preprocessing, a preliminary step for web data mining. This research was conducted by 5 authors, and by the grace of Allah, we were able to achieve fruitful results. Data preprocessing involves transformation of raw data into understandable format. Preprocessing data is fundamental stage in data mining to improve data efficiency. The data preprocessing method directly affects the outcomes of the analytic algorithms. However, the method of preprocessing may vary for area of application. Data preprocessing is a significant stage in data mining process. According to a report, data preparation refers to any action intended to increase the quality, usability, accessibility, or portability of data. The ultimate objective of data preparation is to allow analytical systems with clean and consumable data to be transformed into actionable insight. Data preprocessing embraces numerous practices such as cleaning, integration, transformation, and reduction. The preprocessing phase may consume substantial amount of time, but the outcome is the final data sets which anticipate, correct, and beneficial for future data mining algorithms. This simple diagram represents the knowledge discovery process in any data mining application. We have original data source, which is then pre-processed and transformed, and useful insights or knowledge is extracted from it. Background. The raw data available on data warehouses, data mart, database file, etc. are generally not organized for analysis, as it may be incomplete, inconsistent, or it may be distributed into various tables or represented in different formats. In short, it's dirty. The process of discovering knowledge from the massive chronological data source is called as knowledge discovery in database or data mining. It is the era of big data, and every field of life are generating data at drastic level. The most challenging task is to gain right information from present data source. The task of reorganizing data is known as data preparation. It is used to discover the anticipated knowledge. It incorporates understanding domain based on problem under consideration and then collection of target data to achieve anticipated goals. Froster estimate up to 80% of data analyst time is consumed in preparing the data. Collected data can then be processed for data mining. Data preprocessing is the final solution to increase data quality. Data preprocessing includes cleaning of data, normalization of data, transformation, feature extraction, and selection. The processed data is the trained set for machine learning algorithm. Data preprocessing stages. The first stage for data preprocessing is data cleaning, which recognizes partial, incorrect, imprecise, or inappropriate part of data from the dataset. Data cleaning may eliminate typographical errors. It may ignore tuples containing missing values or alter values compared to known list of entities. The data then become consistent with the other dataset in the system. Precisely, data cleaning comprises of following 4 steps as described in the following table. These are the basic steps for data cleaning. First of all, data is analyzed. Then we define a workflow depending upon the heterogeneity of the data, the sources of the data. Then we execute the defined set of rules, and then finally we verify the procedure applied on a given data set. Step 2 and 3 repetitively execute till all the problems related to data quality get solved. Repeat step 1 to 4 until user requirements are met to clean the data. Handling missing value is difficult as improperly handling the missing values may lead to poor knowledge extraction. Expectation maximization algorithm, imputation filtering are general consideration for handling missing values. Various data cleaning solutions are also applied to validate the dataset on dirty data in order to clean it. Some tools use data enhancement techniques which make incomplete data set complete by addition of related information. Binding methods can be used to remove noisy data. Clustering technique is used to detect outliers. Data can also be smoothed out by fitting it into regression function. Numerous regression procedures such as linear, multiple, or logistic regressions are used to regulate regression functions. Data integration is a method of merging data derived from different sources of data into a consistent data set. Data on web is expanding in size and complexity and is either unstructured or semi-structured. Integration of data is extremely cumbersome and iterative process. The consideration during integration process are mostly related to standards of heterogeneous data sources. Secondly, the process of integrating new data sources to existing data set is time consuming, ultimately result in inappropriate consumption of valuable information. ELT tools are used to handle larger volume of data. It integrates diverse sources into a single physical location, provides uniform conceptual schema, and provides querying capabilities. Raw data is usually transformed into a format suitable for analysis. Data can be normalized, for instance, transformation of numerical variable to a common range. Data normalization can be achieved using range normalization technique or Z-score methods. Categorical data can also be transformed using aggregation, which merges 2 or more attributes into a single attribute. Generalization can be applied on low-level attributes which are transformed to a high level. Data reduction. Multi-facet exploration on huge data sources may consume considerable time or even be infeasible. When the number of predictor variables or number of instances become large, mining algorithms suffer from dimensionality handling problems. The last stage of data preprocessing is data reduction. Data reduction makes input data more effective in representation without losing its integrity. Data reduction may or may not be useless. The end data may contain all information of original database in well-organized format. Encoding technique hierarchically distribution data cube aggregation can be used to reduce the size of dataset. Data reduction, harmonized feature selection process, instance selection and instant generation are two approaches used by data mining algorithm to reduce the data size. Our research objective was to propose a framework for processing web data. World Wide Web is a huge repository of an awful textual data, most of it's being created on daily basis, reaching from unstructured to semi-structured to completely unstructured. How can we utilize the data in productive way? How can we do with it? What can we do with it? The answer to these two questions is totally dependent on what is our objective. This is a basic framework for web content processing. It basically consists of 3 steps. First is noise removal, tokenization, segmentation and normalization. This is just like a cycle. This process goes on and on. To leverage the availability of this data, it has to be preprocessed, which entails various steps, but it may not apply to a given task, but usually plunged below the broad categories of tokenization, normalization, and substitution. Tokenization. In textual data preprocessing, tokenization is used to split long strings of text into smaller ones. For example, sentences can be tokenized into words. It can also known as text segmentation or lexical analysis. Normalization, it generally refers to a series of related tasks in order to place all words on equal footing or uniformity. For instance, performing stemming, lemmanization, changing the uppercase to lowercase or lowercase to uppercase, punctuation, spaces or stop words removal, substitution of number with other equivalent words. Substitution or noise removal. Text data on website is wrapped with HTML, XML tags. Pattern matching or regular expression can be used to extract the desired text by removing these tags. ELT tools are used to handle larger volume of data. It integrates diverse sources into a single physical location, provides uniform conceptual schema, and provides querying capabilities. We have explored PHP natural language toolkit for tokenization. We have used dummy HTML page content, but these steps can be applied and are fully transferable. This is a screenshot of simple HTML page with HTML tags, as you can see. We applied normalization and substitution. The data pre-processing pipeline will start with noise removal as it is not task dependent. The line of code in figure 4 reads in the text line from the sample text files and contain dummy HTML data as shown in the figure. It calls a PHP built-in function to strip off HTML tag. So the snippet here attached is basically reading the content of the file and stripping out the tags from the pages. HTML tag. Substitution or noise removal. Text data on website is wrapped with HTML, XML tags. Pattern matching or regular expression can be used to extract the desired text by removing these tags. ELT tools are used to handle larger volume of data. It integrates diverse sources into a single physical location, provides uniform conceptual schema, and provides querying capabilities. After text denoising, we are left with the following text as shown in the screenshot. This is a screenshot of simple HTML page with HTML tags, as you can see. These source code lines. which is used in calling a tokenizer function in built-in natural and PHP natural language processing toolkits. Raw data is usually transformed into a format suitable for analysis. Data can be normalized for ELT. Tools are used to handle larger volume of data. It integrates diverse sources into a single physical location, provides uniform conceptual schema, and these lines shows the stemming of words. This is a basic framework for web content processing. It basically consists of 3 steps. First is noise removal, tokenization, segmentation, and normalization. Step 2 and 3 repetitively execute till all the problems related to data quality get solved. Repeat step 1 to 4 until user requirements are met to clean the data. Handling missing values. We also stripped out punctuations and converted numbers to words. This is the final output after applying all the pre-processing steps. Conclusion: any data analysis algorithm will fail to discover hidden pattern or trend from the data if the data set under observation is inadequate, irrelevant, or incomplete. Thus, data preprocessing is a central phase in data analysis process. The preprocessing of data resolves numerous kinds of problems such as noise, redundancy, missing values, etc. High quality results are only achievable with high quality of data, which in turn also reduce the cost for data mining. Our research objective was to propose a framework for processing web Step 2 and 3 repetitively execute till all the problems related to data quality get solved. Repeat step 1 to 4 until user requirements are met to clean the data. Handling missing value is difficult as improperly handling the missing values may lead to poor knowledge extraction. Expectation maximization algorithm imputation, and the references for these papers are mentioned here. I would like to thank you, International Multi-Topic Conference on Engineering and Sciences, for providing us the platform to present the research work. Thank you.